Okay, good afternoon class. So at this point we are looking at the June paper 2, the grade 11 paper. At this point we have covered question 1 all the way down to question 3.1.2. Okay. So this is the second video on this paper. So the question says simplify the expression below without the use of a calculator. Okay, that means to say you must not use a calculator. Okay. So in 3.2.1 the question says got sine of 720 plus x. So of course if I subtract 360 from that I get 360 plus x, which takes you to the first quadrant. Or if I subtract 360 again from that, it takes you to just x. That's all stations to Claremont. There's 180, that is 0 and so on. Alright, so that is simply just sine x times 90 minus, that takes you into quadrant 1. Sine positive, negative in that quadrant. Positive changes to cos of x. Plus 180 plus, that takes you to quadrant 3. Cos is negative. Negative times positive is negative cos x all over. 135, that's in your second quadrant. Of course, that is going to be tan 180 minus 45, or some of you just write negative tan x, negative tan 45, minus, that's 360 minus is in the fourth quadrant. Sine is negative, makes that negative a positive, sine of x. Okay. As you see in the numerator, we have cos of x as a common factor. We take out cos x as a common factor, and left with sine x minus 1. In the denominator, of course, that is going to be negative tan 45 plus sine x. Alright, so tan of 45, of course, is 1 over 1. That's coming from your special triangle here, so 1, 1, and 2. So it's going to become cos sine x minus 1 all over negative 1 plus sine x. Alright. So what do we do now? We take out negative as a common factor. So it's cos, or I could swap this around. If I swap that around, no, it's the same. Sine x minus 1 is the same as negative 1 minus sine x, no? So what happens? Cancel. So the answer is cos of x. Just check if that's correct. Who got that sum right? Nobody? This, I almost feel like they're missing something. Okay, is that correct? Well, nobody confirmed first. Leah, what did you get as an answer right now? Mariam? You're welcome back. Where have you been? India, nice? you know, the other one is from India. Anyway, the chickpeas are right. Okay, so let's just check here quickly. Looks right to me. Okay. The question paper and memo can be found in the description box below. Okay. People in 3.2.2, what do we know? We have sine of 30 times sine 230 over cos 140. Again, without the use of calculator, sine of 30 divided sine of 30, or I could have written it since it belongs to a special triangle, so it's 1, 2, root 3 there. So it can be a half times. So sine of 30 is in which quadrant? Well, 230, sorry. Third quadrant, not so? So it's going to be sine 180 plus an angle of 70, not 70, 80 is 50. Is that correct? Over cos. So what I do now is I choose an angle dealing with 50. And how can I use 50 for 140? You can say it's going to be 90 plus 50. Okay, and as you know, the 90 is one of these sides lines. So it's going to be 90 plus. Sine of 30, of course, is a half times. That's in your third quadrant. Sine is negative, so it's negative sine 50 over 180 plus. Takes you to the second quadrant. It's cos positive and negative. Negative, but changes to sine of 50. Okay. Even though sine is positive in the second quadrant. Alright. So what happens? Negative sine 50 cancels negative sine 50, and the answer is, of course, half. Okay. Let's go to the next question, in question 3.38. Okay, question 3.3.1. We got sine of A plus cos of A times tan of A is equal to 1 over cos of A. They ask you to prove the identity. So to prove this identity, we work left and right hand side stored here. So as you can see, on the left hand side we'll change tan. Tan can be written as sine A over cos A. So this is your tan. Okay. People, this can be simplified or rewritten as cos of A plus cos of A plus, that's naturally over 1, sine A times sine A is sine squared A over cos of A. So what's your LCM, people? Cos of A. So I multiply this by cos of A. This will multiply by 1. So cos A times cos A is cos squared A plus sine squared A. So what's cos squared A plus sine squared A? 1. So it's 1 over cos A, which is equal to the left hand side. Okay. Of course, equal to the right hand side. In question 3.3.2, we are given 1 minus cos A, or cos x over sin x is equal to sin x over 1 plus cos x. People, I can work on any one of the two sides. I'm going to go with the left hand side. Okay. Again, there's two things I can do with it. I can either chain and multiply the numerator and denominator by sin x over sin x. Then I get sin squared x in the denominator, and then change this to 1 minus cos squared x, and then do difference of 2 squares. Or I can take the conjugate pair, okay, and multiply this by the conjugate pair of the numerator, so it's 1 plus cos x over 1 plus cos x. So you multiply the first and the last, that then gives me 1 minus cos squared x over sin x into 1 plus cos x. People, 1 minus cos squared x can be written as sin squared x over sin x into 1 plus cos x. So sin x cancel one of the two, leaves us with sin x over 1 plus cos x. Can you see it? And it's the same as the right hand side. Okay. How many of you worked with maths over the holiday? Only 2 people. And here I thought, okay, every morning I'm sitting after early morning. I'm sitting with my maths book and I'm thinking, smiling to myself, you know, do you know how many grade 11s in my class is sitting with the maths book? This. And yeah, I'm only told 2 of you sat with the maths book. How much do I feel? I feel cheated on now. Huh? Right, people, why is there a small if? Supposed to have been capital, no? If 13 cos A minus 12 is equal to 0, if that is the case, then we know that cos of alpha is equal to 12 over 30. You took that over and divide by 30. And tan is less than 0. What does that mean? What does it mean if tan is less than 0? Tan is negative. So let's go. This is the tan is positive, cos is positive, so it's in the first and fourth. Where is tan negative? The second and fourth. So which quadrant are we going to draw in? Fourth quadrant. Okay. We must get this right because this comes in over and over and over. Okay. So in the fourth quadrant we draw. It gets open from the positive on. This is adjacent over hypotenuse. So I get 12, hypotenuse is 13. Apply Pythagoras, I then get negative 5. So that's 13 squared minus 12 squared is equal to your opposite side squared. And then should give you an answer of 25. The square root thereof is 5. Why am I saying negative? Because that's in the negative part of your y-axis. Okay. So the question says determine without the use of a calculator. We got 5 over sine of alpha minus tan alpha. So it's 5 over sine, it's opposite, which is negative 5 over 13 minus tan, it's opposite, which is negative 5 over adjacent, which is 12. So we just put that in the calculator. It's 5 divided by negative 5 over 13, negative 5 over 13, plus 5 over 12. Give me an answer of negative 151 over 12. Okay. Any issues there? Huh? No? Let's carry on with our lives. So here we are told if tan of 50 is equal to k, determine the following in terms of k. So what do? I first set up a triangle in terms of k. Okay. So if you got tan of 50 is equal to k, that's going to be tan stands for opposite over adjacent. I don't have to write this in the quadrant because this question is normally in the first quadrant. Okay. So tan is going to tan the 50 is in the stand position. Of course, 40 lies there. So if you got an angle of 40, we can use that side as well. Tan is opposite over adjacent. So what do? I apply Pythagoras. I then say k squared plus 1 squared is equal to your hypotenuse side squared. Which indeed is going to give you the square root of k squared plus 1. You can't take the square root of that because of the plus or minus between. So let's look at 4.2.1. Tan of 310 degrees. Which quadrant is 310 degrees? The fourth quadrant. So I then say it's going to be tan squared of 360 minus 50. Is tan positive or negative in the fourth quadrant? Negative. But changes to positive. No, it's negative in the fourth quadrant. But because of the square, it will change to positive. So it's tan squared 50. So tan is opposite over adjacent. So it's k over 1 all squared, which is k squared. Over 1, which is simply k squared. Okay. Let's look at the next one. You got sine of 130 degrees. So sine 130 is in which quadrant? Second quadrant. How do you get in the second quadrant? It's either 90 plus 40 or 180 minus 50. Sine positive or negative in the second quadrant? Positive. So it's the sine of 50. So sine is opposite over hypotenuse. So it's going to be k over the square root of k squared plus. Okay. Let's look at 4.2.3. Now here we've got the negative angle of 500. So what do? We add 360. So it's negative 500 plus 360. Plus 360. Total number is positive, is 220. So it's cos of 220 degrees. Which quadrant is 220 degrees? Sorry? Third quadrant. So it's cos 180 plus 40. So cos is adjacent over hypotenuse. Sorry, cos is negative. No? So it's negative cos 40. So it's negative adjacent, which is k over the square root of k squared plus 1. Okay. Any confusion here? Am I moving too fast? No. Okay. Right, your favorite geometry. Which Dimple? Huh? You get the sum right? Nice. If I put your name in here, that means to say, I know you're going to get that sum right. No? That's why I had to now move away from the name we were using all the time. Are you guys sit on the side? You guys are? Right. Number answer the circle geometry question in a rush and left the question incomplete. Incomplete means to say he didn't finish the sum. No? For those of you who don't know. Right, let's get this here. Probably would need much more space than this. Let's pull this up. Right. So angle A is equal to 70. Why? Why is angle A equal to 70? Exterior angle of cycling. P2. P2 is going to be 90 degrees. Why? The angle is semicircle. Right. B is equal to 21. Sum of triangles in this triangle. Or PS. You don't have to say this last part of the triangle is in. Then angle B plus C is equal to angle AY. Alternate angles with PQ being parallel to SR. The last one, angle C is equal to 50Y. No reason midpoint. It's a nice one. Imagine all the geometry was like this. It will be nice, no? Yes, but we were not busy with Mickey Mouse stuff here. Yeah, busy with maths. Right, next question. 5.2. You have been told that in the diagram below, ABC is a cyclic quad. So ABC is a cyclic quad, all cyclic properties are evident here. TAN is a tangent to the circle. CAN is 70 degrees, and then we are told that those lengths are equal. People, if these lengths are equal, what do we know? If that angle will be equal to BAC, which is this angle here. Why? Angles opposite equal sides. Okay. First things first. Determine the size of the following angles with the reason. Angle A, or A, is going to be 70. Why is angle A 70 degrees? Tan chord theorem. Okay. Okay, that's number one. Now this question. That's easy, no? Let's go to the next question. BC. Right. Number two. B. There's B. So we know that opposite angles of a cyclic quad is supplementary. So that one and that one has a relationship that exists between those angles there. Okay. Yeah, let's go a bit slower here. No? So B plus 70 is equal to 180. Well, because it's opposite angles are cyclic. So B works out to be 110. Okay. Then C. I see that this angle is also C. No? But is that on the diagram? No. So I must state. So BAC is equal to C. Why? Because it's angles opposite equal sides. People, this one here, you couldn't have made a mistake and said sides opposite equal. Okay, you will be penalized there. Okay? So we got 2C plus 70 equals 180. Why? Sum of triangles. This is triangle BCA. So 2C is going to give you an angle of 110. So C is 55. 55 correct? Huh? Yes. It's 55 then. And that is 55. Okay. I'm going to take this off here so that I have space to write. As I want to keep the diagram in focus. And then I ask you to calculate angle D. Okay. Lowercase d, what do we have here? It's either this angle and that angle is going to be the same. Answer? Why? And for theorem, what could have bounded angles on a straight line. So there's D is equal to 55 degrees. Then chord theorem. Okay. Any confusion there? No. Alright, next. Proof. Come on, must be a proof. So in the diagram below, O is the center of no proof. The diagram, O is the center of the circle. PQ is a chord. OR is perpendicular to PQ. OR is equal to 6. OR is equal to 6. PQ is 16. Alright, calculate the length of OQ. So to calculate the length of OQ, which is the radius, which is this length here, I need to firstly say that RQ is equal to 8. Remember, this is perpendicular, so those lengths are equal. That's all. This is 8 degrees wide, perpendicular from center to chord by 6th of it. Okay, so this is 8 here. So I'm going to calculate OQ by using Pythagoras. So OQ squared is equal to 6 squared plus 8 squared. Reason? Pythagoras with angle R1 equals 90 degrees. Okay. So OQ squared is equal to 100. So OQ works out to be 10 units, 10 centimeters in this case. Okay. It's fairly simple then. Let's go to the next one. 6.2. In 6.2 we are told in the figure tan, TAN and SPN are tangents to the circle. So people have got two tangents. So these lengths are equal. One, tangents from common point, which is the common point N in this case. Find the angles A, B, C and D in with correct reasons. Okay. People just remember, whatever is not on the diagram, we must state it. Okay. So let's try and do it in order. Firstly, we know that those two lengths are equal. Not so. So I must say that. I'm going to put this over here. Otherwise we're writing most of the time behind the calculator. This is question 6.2. Okay, 6.2. So we say that Pn is equal to An. Why? Tangent from common point. People, the question paper and the memo can be found in the description box below. Okay. So now we know that A is equal to B. Why is this angle equal to that angle? Because angles opposite equal sides. Okay. So we got A plus B plus 50 equals 180. B is the same as A. So twice A plus 50 degrees equals 180. Why? Sum of triangles. And it's triangle PAN. So A works out to be 130 divided by 2, which is 65, which is equal to B. So there is 65. 65. Okay. Now we go and we work out. We got B and we got A. C. C is the same as 65. Now, so, why? Because of the tan chord here. Or we could have used this here as well, the same. Yeah? 65 degrees. It's the tan chord theorem. Okay. So then angle D, we know that A and D will be 90 degrees. Why? Radius perpendicular to tangent. So D is equal to 90 minus 65 degrees, which is 25 degrees. Radius perpendicular to. Okay. Any confusion there? Alright, let's go to the next one. Question 7. People, the link to this proof can be found in the description box below. Okay. This is the second proof in that video. Okay, so that link to that video will be found in the description box below. Okay. 7.2.1. So we are told that in the diagram J, X, Y, M is a cyclic quadrant. So all cyclic properties are evident there, like Y2 is equal to J and so on. Then we are told that Jm is parallel to Kl. People, if these lines are parallel, then co-interior angles are supplementary. Okay. A circle J, a circle through J, M, cuts J, M, L, J, M, L, supposed to have been K. There's a mistake here, no? Should have been K. At X and Y. Okay? Then we are told that angle XOM, XOM, at the center of the circle is 120. So angle at center is twice angle at circumference. Okay. This is 7.2. So 7.2.1. The question says calculate the size of X, Y, L. So it's X, Y, which is this angle. But I already said that Y2 is the same as J. Now, so Y, the exterior angle is equal to the interior opposite of the cyclic chord. Okay, but which angle can I link with J? Angle O, angle at center. Now, so angle J is equal to 120 divided by 2, which is 60. Okay. Why? It's angle at center equals 2 times angle at circumference. There's 60. So I can either call this Y2 or XYL is equal to 60 degrees. Why? It's the exterior angle of cyclic chord. The exterior angle of the cyclic chord is equal to the interior opposite angle. Okay. Let's look at the next question. Let's see how far behind the... We're not too far behind. Next question. Hence prove that J, Y, L, K, J, sorry? X, Y. X, Y, L, K. Thank you. It's a cyclic chord. People, if this is a cyclic chord, what do we know? It can be three ways of proving cyclic chords. What? Opposite angles are supplementary. Exterior angles equal to the interior opposite or the bow tie. Not so. So if I can prove this 120, I've done the job. Not so, because a 60 plus 120 gives you 180. But we know that this is parallel. So what do we notice here? That K is 120. Why? Because co-interior angles are supplementary. Easy. Not so? It's easy now, you say, but not in the exam. Huh? Right, so for number 2, we're going to say firstly that angle K is equal to 120. Why? It's co-interior angles with KL being parallel to J. Is 120. So you see there's a relationship that exists here now. Since angle K plus XYL, or you could have said Y2 is equal to 180. Therefore, XKLY is a cyclic quadrant. Why? This is the one. Why? Because opposite angles are supplementary. Well, you can't say opposite angles of cyclic quad. If you say converse of opposite angles of a cyclic quad, then you would got in the mark as well, no? But that is suffice. Opposite angles are supplementary, which means to say it adds up to 180. Okay. Now I'm going to put dots here to indicate to me that these points forms a cyclic quad, where a circle is now drawn through those points. It can be now drawn through those points. Okay. I'm going to take this off as I need again more space. Right? Next. Then the last question here. For this diagram. People 9.3. In question 9.3 we are told that in the diagram below AD is a diameter. People, if AD is a diameter, what do we know? Angle C has to be 90 degrees. Why? Angles in semicircle. Okay. Then we have the circle, the diagram below AD is the diameter of circle A, B, C, D with center M. So if this is center, we also know that angle at center is twice angle at circumference. So that M2 is going to be double angle D1. Can you see that? Okay, and so on and so on. Then we are told that the AC and BD are chords, BD bisect. So if BD bisect angle D, which is MDC, then that means to say that D1 is actually equal to D2. Not so? Then we are told that AC intersect BM at E. It doesn't say bisect, but intersect, which means to say this cut. Okay. So let's just pull this over here. The first question says, prove that DC, so this is 7.3, you must prove that, required to prove that DC is parallel to MB. So we are required to prove that DC is equal to, DC is parallel to MB. People, to prove that lines are parallel, we prove one of three cases are true. It's either alternate angles are equal, corresponding angles are equal, or co-interior angles are supplementary. One of those cases. So, where do we start? If we're looking at DC and MB, so if I can prove this, that D2 is equal to that, I've done the job. Not so the lines has to be parallel. Okay, so how do we start? We start off by letting D2 or angle B equal X. Okay, I'm going to go with D2 first. So I can just first say let angle D2 equals X. So if D2 is equal to X, what do we know? D1 has to be equal to X. Why is D1 equal to X? Because it's given that DB bisect angle CDM. Okay, that's also X. But remember that that's the center of the circle. So angle B has to also be X. Why? Because that's going to be angles opposite equal sine. which is coming from the fact that it's your radius. You must mention the radius. Okay, so that is equal. So now we say since, we state the obvious, since D2 is equal to angle B, which is equal to X, therefore DC is parallel to MB. Why? Because the alternate angles are equal. Alternate angles are equal. Okay. So let's look at 7.3.2. Question 7.3.2. Here we are asked, ME is perpendicular. Now what does perpendicular mean to say? Cut at 90 degrees, okay, or meet at 90. ME is perpendicular to AC. ME is perpendicular to AC. Yes, these lines are now parallel. Huh? So, if perpendicular means you say it's 90, huh? We must prove this is 90. Or that is 90 degrees, the same. But what do we know at this point? We know that angle C is 90. Why is angle C 90? Angle in semicircle. But this is also 90. Why? Because it is going here. You guys understand? Let's lay that out nicely. So what do we say? We firstly say that angle C is equal to 90 degrees. Because it's angle in semicircle. Then we say that E1 is 90. Why? It is co-interior angles. With DC being parallel to MB. So therefore, ME is perpendicular to CA. Simple. No? But if that is 90, what do we know? CE has to be equal to EAY, perpendicular from center to chord by 6 to 4. Okay. But let's see what's the next question. The next question says that MB, so let's clear this here a bit. That MB by 6 CA. But we just spoke about that now, not so. So we can say that CE is equal to EA. Why? Because it's perpendicular from center to chord by 6 to 4. Okay? That's all you need to write. And then therefore you can say therefore MB by 6, which means cutting off CA. Okay. We're going to just say MB by 6 CA. Why? Perpendicular from center to chord. We'd have gotten full 2 marks there. Okay. The bonus question. Alright, so in 8.1, here we are told that in the figure DBC, BH, where am I reading DBC? BHC is equal to. So they want to know what the size of this angle here. Answer. In terms of A. Now you see this is 90 and this is 90. So what I see here is actually a cyclic chord. Okay. But they want it in terms of A. Okay. So if that is a cyclic chord, that's a cyclic chord and this is a cyclic chord. Can you see? So if that's a cyclic chord, then this angle here is going to be 180 minus A. Why? So this is opposite angles of cyclic quadricyclic. So if that's 180 minus x, then then this has to also be 180 minus a. Why? Because that is vertically opposite. So the answer is B. Okay, that was a simple one, and some of you got that one up. And this one here, this was a nice one. I like this one. Then again, I like all the sums. Right, in 8.2, we are told that the value of 1 plus 2 plus 4, 1 times 2 times 4 plus 2 times 4 times 8 plus 3 times 6 plus 12 plus, and so on, is right. So what do we notice here? For each and every one for the numerator, it's going to be 1 times 2 times 3, which is common in the first, second, third, and so on. Because if you look at 1 times 2 times 3, if I times it by 1, I get this. If I times it by 2, I get that. No, not 4, not 3, but 4. Is that why you're saying, Yes. If I times this by 2, then I get 2, 4, and 8. If I multiply this by 3, I get 3, 6, and 12. If I times it by 4, I get 4, 8, and 16, and so on. If I times it by 10, I get 10, 20, and 40. Can you see that? So in other words, 1 times 2 times 4 is actually a common factor. So that is going to be 1 plus 2 plus 3 plus, and that's going to be plus 10. Let's look at the denominator. The denominator, what is common here? You got 1 times 3 times 9. So if I multiply this by 1, I get the first one. If I multiply by 2, I get the second. If I multiply this by 3, it's going to be 3, 9, and 27, and so on. If I multiply by 10, I get 10, 30, and 90. So which means to say that's going to be 1 plus 2 plus 3 plus 10. So what do you notice now? Hang on. That cancels. So what do I have? 8 over 27. Which makes the answer D. Right. Simple mathematics. Alright, so that basically brings us to the end of paper 2. Again, the question paper and memo can be found in the description box below.